Hey, you're going to have a look at the 2011 paper applied maths question for part B. And this is the kind of scenario that they presented you with in the question. It's a very difficult, it's complicated. There's lots of particles in this. So that's what you see in the diagram. If we look at the question, it says this is a mass of 2, this is a mass of 5, this has got a mass of 1, this has got a mass of 3, this has got a mass of 4, and this has got a mass of 6. In the question, they want us to find out the tensions that are in each of the strings. Find the tension in each string when the system is released from rest. So we could indicate them here. There's this string here that goes up and over. I think I'm going to call that T. That's a common name for tension, isn't it? And then I've got this other one that's over here. Can't call that T, gonna call that OR. And I get this other one called S. So what's really going to happen is, it's pretty obvious this whole side is more massive than this side, and so there's going to be an acceleration in this direction, and that's going up in this way. And maybe I should show that really above this T rope. It does factor into both of these, but we'll discuss that now. Here locally, we're going to see that there's this 6 is going to go down with an acceleration, and this 4 will go up with acceleration. And locally inside this little sphere, that's not a sphere, that's a box. Inside this little world here, we'll say that goes down with an acceleration of b, and that goes up an acceleration of b. In a global structure where we incorporate, and that's what we're doing in these questions, we're trying to box off then the mass, then the acceleration of this is 6 times a plus b, and this will be 4 times, and I'm going to have to go with b minus a, and I'll show you why that may be in a moment. It's a simple enough pulley system, so let's just break it out. I think I'd be most comfortable to start with the two biggest masses, and so that would be the acceleration of the two mass particle, and that's going to be a 2a, the net force, and that going to relate to its mass and its acceleration. Well, what's causing this two mass to move in this? It's the tension, so it's been pulled up by this rope T, and what's preventing it from rising with the whole T is the 2g. The same thing for the 5a. So 5a is equal to, what's causing its motion is 5g minus the plus 2s minus t. This is also being hampered by two other forces that are going backwards, and they're also, so it's 2 or. Okay, so now we've got to work on the others. I suppose the next one to work on is these, and so we'll say that I never put a ladder with these, so that's going up with a velocity, with an acceleration of c, and that's going down with an acceleration of c. So let's try and get these out. So 1, this mass is going upwards and upwards, so it's 1a plus c, and that's equal to, what's the force causing that? Well, the only force causing that is actually or. It's the only force that's operating on this, minus g. The same workings on the other side, so it's 3 times. Now, I said this earlier, I'd like to show you why I'm going to define which way I want to write it. I really want the minus or to pop up here. I think I do. So that's going down. That's the force down. So what's going down? A 3c minus a. And that's equal to, the force going down is 3g, and the force going back up is plus or. Do the same for the S's, this side here. So it turns out to be 6A plus B is equal to, well, 6G minus S, and this is 4B minus A, and that's equal to S minus 4G. Okay, so they're your first few phrases. I suppose we want to try and reduce this. We're looking for the tensions, so these tension forces are what we need to resolve. In order to simplify, probably best to simplify and get rid of the C's here. We're looking to get rid of the C's and not the tensions. We want to keep the tensions in formula for as long as possible. So I'm going to try and get rid of this. Okay, so I've got A plus C is equal to or minus G. I've got 3C minus 3A is equal to 3G plus or. I want to get rid of the C's, therefore minus 3A minus 3C minus 3 or minus 3G. Ooh. Minus 3G makes it a plus 3G. So I'm left here with saying that minus 6A is equal to minus 2 or plus 6G. Rewrite that to say A is equal to, 3A is equal to or minus 3G. That's supposed to be minus sign, isn't it? Yeah. Minus 4 or 3A is equal to 2 or minus 3G. Okay, good stuff. So now what we'd like is a formula, a similar formula for the S's. So how do I do that? This is where I'm trying to get rid of the B's, yeah? So we've got 6AB plus, 6A plus 6B is equal to 6G minus S. I've got 4B minus 4A is equal to S minus 4G. Now you're very tempted to get rid of that S as we combine them. We used to always do that, but in this case we're not looking for that. We're trying to preserve the S, and what we want to do is get rid of this other unknown. That's our target. So rewrite this to multiply the top by 4 and the bottom by minus 6. So it becomes 24A plus 24B is equal to 24G minus 4S. Minus 6 times makes that 20. Minus 6 by 4 is minus 20. Minus 24 by positive minus by minus 24A minus 24B is equal to minus 6S minus 24G. That's a minus by a minus, so that's plus. So that leaves us with 48A is equal to 48G minus 10S. So 10S is equal to 48G minus 48A. 5S is equal to 24G minus 24. So what we've got here is a couple of breakdowns in what S is and what OR is. So we could also say that 2 OR is equal to 3a plus 3g. Okay. We can now bring that back up into one of our formulas from here. So the 2a formula, the 2a is equal to t minus 2g minus 2r. Well, if I say the 2r is 3a plus 3g, then hopefully I can guess that 2a is equal to t minus 2g, that's all as it was, minus 2r, where I said 2r was equal to 3a minus 3g. So it's minus 3a minus 3g. So just simplify that a bit. Bring the a's across to get 5a is equal to t minus 5g, or the t is equal to 5a plus 5g, I think. Now we have to find our equations for t or an s. T we've figured out, sorry, yeah, so or we figured out to be 3a plus 3g all over 2. S was equal to 24g minus 24a all over 5, and t was the last thing to find. If we have a little look at equation 1, the 2a is equal to t minus 2g minus 2r. Well, I just said the 2r was this, so or was that, so let's go and make this 2a is equal to t minus 2g. 2 of that is equal to minus 3a minus 3g. That makes 5a is equal to t minus 5g. Okay, so that's the first bit done. So tension is equal to 5a plus 5g. So what's wrong with all these is that we've no a. Okay, so to find a, we need to do a couple of little calculations. We had an equation back on the first page, if I could find the first page, when we were dealing with this side, and that came out to say 3a plus is equal to 2r minus 3g, and it was from combining these two phrases. So 3a is equal to 2r minus 3g. Another phrase we had previously that had r's in it, and we could use that to cancel, was that this 2 r's. We combine that and we see what we get. So this is the very first equation. It's the equation of motion of the 2 kilogram pulley particle. So 2a, so that's 2a is equal to t minus 2g minus 2r. So now this says 5a is equal to t minus 5g. So here's some interesting stuff here. 5a is equal to 5g plus 2s minus t. So that's the 5 kilogram particle motion is equal to 5g plus 2s minus t. The 5a is 10a is equal to, the t's are gone, the 5g's are gone, 2s, s is equal to 5a. Okay. We then had so we had three formulas, R, S and T. I suppose the one that we're kind of most curious about is the 5S was equal to, that's supposed to be a 5, S is equal to 24g minus 24a. Instead of saying S is 5a, so therefore 5s is equal to 25a is equal to 24g minus 24a. Rearrange that to say 49a is equal to 24g. A is equal to 24 over 49g. So that's equal to 4.8 meters per second squares. You use that then in here to figure out the R, which was two of them was 3a plus 3g all over 2, and then finally your t. You then have to get that t equation over there. Did I not show it to you? Oh, I did 5a plus 5g. So put that in to get those three out. Hope that helps.